Oh, hello. I didn't see you there. Come in. I'll make you dinner. This is my grandmother's stew. Although I cannot tell you the recipe, I can tell you it's a very complete recipe. It has chicken, carrots, broccoli, spices, and most especially, onion. You know, all these ingredients have something in common. It's a funny thought, really, albeit a very obvious one, and it's that all of these ingredients come from planet Earth. Oh, the cake is ready. Careful, this is hot. You see, much like on planet Earth here, this onion has multiple layers, both on the inside and the outside, that help ensure its survival. And it all starts right here, right where we're standing, the lithosphere. You know, we humans are terrestrial creatures, and well, it basically means that we do not live underwater. The lithosphere, or stone sphere in Greek, provides us with a solid foundation in which to build on. On the lithosphere, we do 98% of our activities. On the lithosphere, we farm, we build, we walk, we sleep. On the lithosphere, we live. Now, as solid as the lithosphere is, it is not completely solid. Let me explain. The lithosphere is not a single slab of rock, but rather a compound structure made of smaller plates, tectonic plates, if you will. Now, these continental plates do not rest on solid foundation. Right beneath the lithosphere lies the mantle, another one of Earth's layers. The mantle is entirely made out of molten rocks, of magma. And as you can imagine, it is very, very hot. The mantle transfers some of its heat to the lithosphere by a process called convection, in which the magma has some sort of current which brings the molten rock upwards in order to hit the lithosphere. And that prevents the lithosphere looking like a frozen popsicle. Also, the tectonic plates of the planet are not sitting on the mantle as much. Because the tectonic plates are not sitting on the mantle as much as they are floating on it, this gives the lithosphere a couple of pretty interesting characteristics. Because the plates are not entirely fused together, they can expand and deform, giving way to a property which we call ductility. Because the plates are suspended on what is basically a very hot liquid, they will interact with each other in events which we call tectonic activity. Tectonic activity, based on its scale, can be very devastating for humanity. The interaction between the plates gives birth to mountains and volcanoes, but it can also create earthquakes and tsunamis, which can lead to tens of thousands of deaths in unprepared countries. You know, this has made me very, very thirsty. I think I'll have some water. It's kind of funny, really. If any of us were not to drink this colorless and flavorless liquid, we would die in around, give or take, 3 days. And that is the second sphere, the Hydrosphere. Now, given the meaning of lithosphere, I'm sure you can already guess what the Hydrosphere is going to be made of. Water. The Hydrosphere contains water in many sorts: lakes, rivers, oceans. Now, although we play the majority of our activities in dry land, the Hydrosphere is a key component for human survival. We use it for drinking, recreation, farming, hygiene, and cooking. Now, even though 70% of our planet is covered by water, only 3% of that water is actually safe for human consumption. The other 97% is either very salty or just plain out, disgustingly filthy. Now add to the fact that 69% of that 3% of water is found in glaciers and ice caps. And 30% of that water is found underground. That leaves us with a 0.9% of easily accessible water to satisfy our daily needs. You'll see, water is a vital resource. So vital in fact that it makes up 70% of our entire body mass. And as vital as it is, not everyone has access to it. Because depending on the place that you are, you're going to receive a different amount of rainfall. This is known as runoff variability. And this can affect any country that has little to no water available to them. Also, when talking about water, humanity as a whole faces an enormous problem. You see, water is classified as a renewable resource, which means that when consumed, Earth has the ability to replenish its supplies. However, we are consuming it faster than Earth can produce it. Oh, look at the time. I have to get the corn out of the freezer. You see, although the corn and I were in the same room, the corn was frozen. A similar thing happens in our planet. Let me explain. Every place on Earth has a different climate, and therefore a different temperature. Climate is the average weather conditions of a place. If the same conditions are met over a span of 30 years, it is called a normal. Weather, on the other hand, is the specific climatological conditions of a place at a given time. Climate can be affected by many things, including humidity, altitude, pressure, and the proximity to water bodies. Pay close attention to this graphic. All of these variables give way to what we know as climate regions. In our world, there are 6 main climate regions: the taiga, the rainforests, the tundra, the desert, the savanna, and the steppe. Oh, the stew's ready. Can you see that? The vapor. You can clearly note that it is slowly rising to the sky towards the outermost layer of our Earth, the atmosphere. The atmosphere is, you guessed it, the vapor sphere in Greek. It is basically a layer of gases that is surrounding our planet. What holds the atmosphere close to our planet and prevents from simply floating away into space is Earth's gravitational pull, forcing the gases towards Earth's core. Greeks weren't so wrong either, as the atmosphere is in fact made of gases. The atmosphere is a mixture of gases, 78% nitrogen, 21% oxygen, 0.9% argon, 0.03% carbon dioxide, and 0.4% water vapor. In the atmosphere, there's a smaller layer called the ozone layer. The ozone layer has the characteristics of being able to remove harmful solar radiation on ionized particles. If the ozone layer weren't there and we were to take the solar radiation at full force, well, the result would be something like, well, like this. Yuck. Much like the Earth itself, the atmosphere is also made up of various layers, all of which have a certain function. The innermost layer is called the troposphere, which makes up the very first 12 kilometers of air. Up next is the stratosphere, which starts at the end of the troposphere and extends all the way up to 50 kilometers above sea level. This is where the ozone layer is found. It is also the layer in which planes are able to fly because they can avoid natural phenomena that happens in the troposphere. Above the stratosphere is the mesosphere, which has the coldest temperatures on average. Linings are produced here. It extends all the way up to 80 kilometers above sea level. The second to last layer is called the thermosphere. It is the hottest layer of the atmosphere, and it ends at 700 kilometers above sea level. Last but not least, there's the exosphere. The exosphere is the last layer of Earth. At the end of the exosphere, we find the Kármán line, which is the official boundary that separates Earth from outer space. Finally, we did it. We reached the edge of our planet. And yet, we are not done. For the sky is not the final frontier, but rather what is above it. You will see the Earth is only one of 7 planets that exist within our solar system. At the center of it, we find the Sun, the central star of our planetary system, and one of the reasons we are alive. The Sun, and more specifically, the sunlight and heat it produces, are essential for life on Earth. Not only does it warm up our planet, allowing for there to be liquid water, but they also provide energy for the plants. We are very lucky. Our planet is found within the Goldilocks zone, which means it is sitting just at the right distance for the sun for there to be life. Any closer, and our planet would be burnt to a crisp. And any farther away, and our planet would become a chunk of ice. All of the planets and stars in our system can be summarized with a gross oversimplification. They are all huge balls of rock and gas. As such, all astral bodies have a gravitational pull. Gravity is a property of matter which attracts everything to itself. The bigger the object is, the stronger its gravitational pull is. Gravity is the reason why all planets are spherical or oblate spheroid, if you want to be more precise. Back to gravity. The Sun is by far the biggest body in the system, and as such, it has the biggest gravitational pull. It is so big, in fact, that all of the planets rotate around it. The movement around the Sun is called translation, and for Earth, one cycle is around 365.25 days, or a year. The extra 25% is accumulated, and for every 4 years, we have a leap year. At the same time, the Earth spins around an imaginary line called the axis. The rotation of the Earth around its axis takes about 24 hours, changing the phases of the Earth that receive sunlight as it rotates, giving way to day and night. Also, the axis is significantly tilted, changing the amount of sunlight in different regions that receive and giving way to seasons. And with that, dinner is ready. Thanks for joining me.